Welcome to another PokePoke devlog / here's how I did it video. This is where I look at a feature of PokePoke, demo currently available on Steam, and show you how I accomplished it, while disclaiming that it's just how I did it, and not necessarily a tutorial that I think everyone should rely on, or that covers every little detail, etc. Generally, these are aimed at more advanced developers, while hopefully maybe inspiring or being helpful to others as well. As you can see, PokePoke has lights, notable right now on the player, and tiles are able to cast accurate shadows. Entities like these statues can do this as well, although that takes some setting up on my part to define a mask for that particular entity. I made a video a little while ago about a light and shadows engine that exists made by Jobo, which I still recommend, and for a long time I was using it in PokePoke. After a while though, as my game grew in complexity, carrying around the weight of a generic system built to work with as many games and situations as possible, that I hadn't written myself and had to keep dealing with conflicts between the way it wanted to render things and the way I wanted to render things, I decided to write my own lighting system that could be lighter due to only needing to fulfill my own specific and relatively simple requirement. How I did this is a lot to cover in one video, so forgive me if I'm a little bit brief on some aspects. Firstly, I experimented in a project separate from PokePoke just to get the concept working in and of itself. What I wanted was to be able to create a dark ambience lit up by arbitrary gradient light sources and cast shadows off of a tile map. I created an environment using the art from PokePoke and some light bulbs that would function as the lights, putting one of them at my mouse cursor and also varying their size and color to thoroughly test everything. The lights have very simple definitions that just give them a radius and a color, etc. The work is done by an object called OShadowRender. The idea being that I could put this object on a specific layer and draw my lights and shadows to that particular layer so I could control what exists in front and behind of it. The way the object works is to first of all define a vertex buffer. A vertex buffer at its simplest is a set of points in 3D space. Each point is a vertex. These make up triangles that you can then submit to the drawing pipeline for use with a particular shader. This is usually a part of how you draw in 3D with GameMaker. So how does a vertex buffer help us with shadows? Well, what it allows us to do is define a 3D plane made of two triangles for every side of a wall in the game. This is every side of a tile. This plane stretches for a pseudo-infinite distance on the 3D z-axis, that is to say, into the screen, if that makes sense. Then when it comes time to cast shadows for every visible light source, we can draw all of these 3D planes with a shader that will adjust those vertices to project them at an angle based on the position of the light source. This is the vertex shader that does that, and it creates an image that will look like this. I'm pretty sure I just stole this one-line shader from some forum post, but it works. It takes my infinite 3D planes and it scales the position of their vertices by how high their Z position is, and scales them around the position of the light. I'm putting all of this onto a surface, which then I can run through another shader that will just draw black to the surface in increasing opacity the further away from the light source. I probably could combine these shaders together if I wanted, but I was just trying to keep each step simple as I wrote it. Then I take this surface, modified somewhat for ambient light, and draw it on top of my game. There's a number of ways you can use the surface to similar effect, depending how you want your lights and shadows to look. You can draw additively on top of a scene that already accounts for ambient light, or you can draw it subtractively, which is to say the lights poke holes in a rectangle of ambient darkness. The latter is what I'm currently using, but it does seem to restrict how bright I can make my lights or how effective colored lights are, as they can only really be as bright as the artwork itself. Worth keeping this type of thing in mind. Anyway, using this technique is super effective, especially with static walls, because you only really have to make the vertex buffer once, and all the shadow casting is done by a one-line shader based on the light position every frame. The performance is really good here compared to a lot of methods. Actually porting this to PokePoke itself did involve some extra steps. My rooms are pretty large, and as relatively lightweight as this system is, I didn't want to have such a huge vertex buffer containing 4 walls for every tile being drawn every step. So upon loading a room, I generate a number of vertex buffers based on the size of the room, and when it comes to rendering shadows, I render the buffer that represents the area closest to the player, or sometimes 2 if they're near an overlap. Generating vertex buffers for an 8,000 by 10,000 room with a lot of regions that are entirely full of tiles, which I could certainly optimize, only takes up about 14 megabytes of memory. And even drawing these generously large vertex buffers that could be scaled down much further occupies very little of my performance budget. I had to also accommodate slope tiles, though that was pretty straightforward. I just make a triangle of planes rather than a square whenever that specific type of tile comes up. But also the issue of entities comes up. It's easy enough for me to define a square or a triangle, but what about arbitrary sprites? Well, for this I actually made a tool that would let me draw some points around a sprite and then generate from it the vertex positions I needed. It's a lot of manual work, but it's the only real way way to do it with this system that I could think of. I can then tie a sprite to a definition that tells my shadow renderer what type of vertex buffer to submit for this entity. I define all these at the start of the game, and then for all my entities I submit the appropriate buffer for every nearby light source along with my tiles buffer. I don't currently do a lot to optimize this, but there's a ton I could do to flag entities that are too far away from any active lights to bother submitting and so on. But like I said, performance hasn't really been an issue yet, and I have 100 easy bridges I can cross to help fix that if and when I need to. Moving shadow casters isn't something I've dealt with yet, but I think you could do that by passing through an XY offset to the shader when drawing a particular entity, based on its original XY position, which wouldn't make them any more expensive than static casters. Anyway, I'm really happy with this system. It's super lightweight compared to downloading a pre-built system just because it's built for my needs only and is really simple and I understand it and feel in control of it. Should you write your own lighting system? Well, if you feel like you understood this video well enough to try, then maybe, but I'll leave that one up to you. I hope any of that made sense or was useful, or at the very least interesting to you. Thank you for watching, and thank you to my patrons who funded this video. If you want to see my work get bigger and better and play a role in deciding what I make videos about, consider supporting what I do on Patreon. That's all from me, thank you again, and I'll catch you all next time.